let's talk about factoring. First of all, I love factoring. Factoring is actually I think my second favorite F word. Just only next to fractions. But French fries is pretty close, but that's also two F words. Okay? So, let's start with these two examples. Okay? If I look at this first example right here, what do you think I should do first? And this will be what I do first, literally every problem that I do. What's my first step? Always. Don't panic. Okay? Now my second step is I'm going to look for the greatest common factor, GCF. Have you ever heard of that before? Of course you have. Yes? Okay. We're looking for the greatest common factor. Is there something that divides evenly into both of these terms? Not a number, right? No, there's nothing that divides into 4 and a 5, right? But what about an x? Could I divide an x out of each term? What would it look like if I divided an x out of each term? What would be left? 4x squared minus what? 5. That's it. Yeah? Look at the second example right here. What's common in these two terms? Yeah, this time they're both divisible by a whole number, right? Or an integer, however you want to look at that. Okay? And what number is that? 3. Are they also divisible by an x term? Yes. What's the biggest x term I can take out of both of them? Now, some people get confused at that question because I'm asking for the biggest, right, the greatest common factor. I'm asking what's the biggest exponent I can take out of both of them? Well, isn't it going to be the smallest exponent? Yeah, it is, right? Because I can't take out x to the 5th from x to the 3rd. There's not enough x's. Okay? So if I take out 3x to the 3rd, what's left? Well, 3 divided by 3 is 1, so there's no numbers left, right? What's x to the 5th divided by x to the 3rd? Absolutely, x squared. Okay? And then what? What's left when I divide this term by 3x to the 3rd? Minus 3, right? 9 divided by 3 is 3. X cubed divided by x cubed is just 1, so it's just x squared minus 3. Does that make sense? Okay, so first, after I choose not to panic about the problem, then I look for the greatest common factor. And I'm going to do that on every problem that we do. Okay? But see, then there's some special cases. And if we know the patterns to the special cases, it will make our life infinitely easier. Okay? So here's one of those special cases. It might look like this. X squared minus 9. Okay? Now, when you see x squared minus 9, I want you to recognize, first of all, that it is a binomial, which means there are two terms, right? I want you to look at it and say, is there a greatest common factor? In this particular problem, no, that's correct. There's not a greatest common factor. But there should be like little alarm bells going off in your head. Because what you should recognize is that these two numbers are both special type of numbers. Do you know what type of numbers they are? They're both the same type of number. They are both squares. X squared, it's pretty obvious that it's a square, right? Is 9 a square? What does it mean for something to be a square? Can you take the square root of it? If you can, it's a square. Can you take the square root of x squared? What is it? X, right? Can you take the square root of 9? What is it? 3, yeah. So both of these are squared numbers. Now look at the sign in between these two numbers. What sign is that? a minus, right? So what you have just discovered is the difference of squares. And if you can recognize that this is the difference of squares, oh, so much easier than trying to do some weird, crazy, weird way. Because if it's the difference of squares, to factor it, here's what you do. Two binomials. There's a term here, a term here, a term here, and a term here. Guess what goes in the first part of each binomial? Yeah, the square root of x squared. What is the x squared of x? What is the square root of x squared? X. So an x goes here and an x goes here. What do you think goes in the back of each binomial? The square root of 9. What is the square root of 9? 3. A 3 goes here and a 3 goes here. What are we missing? The signs, right? Any guesses? Yep, they're opposite. Whatever they are, they're opposite signs. Okay? This one could be minus and this one could be plus, but this one could be plus as long as this one is minus. They just have to be opposite. Okay? Now, so why does this work? Can I show you that real quick? What if I multiplied this back out? We're not going to do that in normal problems, okay? Unless you just want to check your answer. If I multiplied this back out, what's x times x? X squared. What is x times 3x? Oh no, I just said the answer. Let me try again. What's x times 3? 3x. What is negative 3 times x? What happens with 3x and negative 3x? Yeah, that's 0, isn't it? So then what's negative 3 times positive 3? Negative 9. So we just got back to our answer. Opposite signs make that middle term that we're used to having go to 0. And I just have a squared term and then the constant. Can I do another one for you? Yes? Okay, awesome. What about this one? 25x to the 4th minus 16. Now, the hardest time that people have usually with this is recognizing that it's the difference of squares. Well, first of all, is it a difference? How do you know if it's a difference? Because of the minus sign. That's exactly right. So is it a difference? Yes. Then we have to decide, are they squares? Is 16 a square? What's its square root? 4. We're going to need to know that in a minute anyways, right? Okay. Is 25x to the 4th a squared term? Well, 25 is for sure, right? What's the square root of 25? 5. So this is the one that comes into question, right? Is x to the 4th a squared term? What times itself is x to the 4th? X squared. So is this the difference of squares? Yes, if it's the difference of squares, then I have two binomials, right? What goes in the front of each binomial? I got to take the square root of that term, right? What is the square root of that term? 5x squared. Perfect. And that goes in the front of each of the binomials, right? What goes in the back of each binomial? 4. Tell me about the signs. Opposite. Now, did it freak you out that I just wrote them different from what I did the first example? I did it on purpose, didn't I? I made this one a minus and this one a plus because I said to you it doesn't matter, they just have to be opposite. So I want to make sure you know it doesn't matter. This one's a positive and this one is a negative. It doesn't matter which one comes first as long as they are opposite signs. Does that make sense? Do you think you could recognize the difference of squares? Yes? Okay, awesome. So what about this problem? Is it the difference of squares? Oh, no? What is it? It's a what? So that means it's the sum of squares, right? If you thought difference of squares was easy, sum of squares is cake. And I'm sorry for saying cake and not having any cake to share. Okay? Because the difference of squares, we just take the square root of each and have opposite signs, right? Square root of each, opposite signs. The sum of squares is even easier because it cannot be factored. And we just write prime and go to the next problem. Because prime means what? Cannot be factored. Okay? So if you see a binomial and these are both squares, that's awesome that you notice it, but then it's also a plus sign in the middle. That's the sum of squares, and we can't factor that. That's prime. Okay? So what about this one? Do you think you could use some math words and figure out what this is called? Use some context clues. What is it? Difference of what? Are they both squared or are they cubed? It's a difference of cubes. Now, would you rather me teach you a formula to memorize or would you rather me teach you a pattern? Pattern, okay. Here's the pattern. You ready for the pattern? If you recognize that it's a difference of cubes, you have a binomial and a trinomial this time. Difference of squares is two binomials. Difference of cubes is a binomial and a trinomial. Okay? So first things first, I'm going to get a different color pen here. What's the cube root of x cubed? X, right? So it goes in the first term of the binomial. All we're filling out right now is the binomial. What do you think goes in the second term of the binomial? Yeah, it's the cube root of 8. What is the cube root of 8? What times what times what? All of itself is 8. 2, right? That's exactly right. Okay? So I filled in my binomial. Now I'm going to use my binomial to fill in my trinomial. You ready? Take this first term and square it. For the second term in my trinomial, I'm going to take these two terms and multiply them together. And for the last term in the trinomial, I'm going to square the second term in the binomial. So what are we missing? The signs, okay? Here's the pattern of the signs. In the binomial is the same sign as the problem. The next sign is opposite of that, and the last sign is always plus. You okay with that? Can we do another one? Okay. Let's do this one. 27x cubed minus 64. So first thing I need you to do is recognize, is this the difference of cubes? Now some people, you know what they try to do? They try to take out a greatest common factor. And is that a good idea? Absolutely, right? Every time we should look to see if there's a greatest common factor. Is there a greatest common factor between these two terms? No, not this time, right? There's not a number that they're both divisible by, right? Okay. So after I have my binomial, after I've decided it's the difference of cubes, what do I give myself? What pattern do I give myself? Binomial, trinomial. You got that okay? So what goes in the first term of the binomial? What is the cube root of 27? What times itself is 27? 3. So in the first term of the binomial goes 3x. Perfect. What goes in the second term of the trinomial? What times itself is 64? Yeah, 4. Okay. Go to the trinomial. How do I fill in the first term of the trinomial? Square that one. Square the first term of the binomial. What do I get? 9x squared. How do I find the middle term of the trinomial? Multiply them together. What's 3x times 4? 12x. And how do I find the last term of the trinomial? Yep, square the last one. What is that? 16. What are the pattern of the signs? So the same in the binomial as in the problem. The next one, opposite of that. And the last one, plus, always plus. Now, you want to know the best part of this? The best part of it is the next example that I want to show you looks like this. 8x to the third plus y to the third. And some of you are already thinking right away, that is not the difference of cubes. Well, what is it? The sum of cubes. Now, the sum of cubes is factorable. It's not like the sum of squares. Okay? It is factorable, but because you asked me to teach you the pattern and not the formula, you already know how to do it. Because guess what you get? Binomial, trinomial. Guess what goes in the first term of the binomial? 2x. And where did that come from? The cube root of the first term, right? What goes in the second term of the binomial? Y, because y is the cube root of y cubed. What goes in the first term of the trinomial? Yes, 4x squared. What goes in the second term of the trinomial? 2xy. And what goes in the last term of the trinomial? Y squared. What is the pattern of the signs? Yeah, whatever was in the problem goes in the binomial. The next one is opposite of that, and the last one is always plus. I didn't have to teach you a new formula to memorize. It's the same pattern for difference of squares as it is for difference of cubes as it is for sum of cubes. Amazing job. Very good. Okay? So do you know what to do if you see binomials? When you see binomials, try to see, is it the difference of something or is it the sum of something? If you decide it's the difference, is it difference of squares or is it difference of cubes? You know the pattern for all of them now, yes? So what happens if there's 4 terms? Do we panic then? No. Step number 1 says, don't panic, right? Wouldn't it be easier if there was not 4 terms? It would, right? 4 terms we panic, but we're following rule number 1, so we don't panic. What if we did this? What if we just paid attention to just the first 2 terms? And I said to myself, self, is there a greatest common factor in these two terms? Oh, yes, there is, isn't there? What are they both divisible by? X squared, right? X squared is the biggest term that I can pull out of each of these two terms, right? What if I divide the first term by x squared? What's left? X. What if I divide x squared by x? What's left? 1, because anything divided by itself is 1, right? It's not just gone. It doesn't disappear. I'm dividing it by itself, so that's a 1, right? Then what if I just ignored those two and just looked at the last two terms? Do these two terms have a greatest common factor? What is it? 2. What's left if I divide a 2 out of each of these two terms? What's 2x divided by 2? X. What's 2 divided by 2? 1. Now, I still have two terms. I have the first term and I have the second term, right? Do these two terms have something in common? What is it? An x plus 1. What if I factor an x plus 1 out of each term? What's left? X squared plus 2. Done. Now, I'll tell you this. I always have somebody every year that wants to know where the other x plus 1 went. Well, there's 2 right here. Where did the other one go? Well, guys, if I'm factoring something out, it doesn't go anywhere, right? I'm factoring it out. If I multiplied x squared times this first term and 2 times this first term, isn't that exactly what this line says? X squared times x plus 1 and 2 times x plus 1. So all I did was factor an x plus 1 out of each term, and then I wrote down what was left when I factored that term out. Does that make sense? Can we do another one? Maybe that will help. Is that all right? Okay. What if this other problem looked like this? 2x to the third plus 6x squared plus x plus 3. So it has 4 terms. How are we going to factor that? I didn't tell you the name. We just did it, right? What did I do here? I just looked at the first 2 terms and then I just looked at the last 2 terms, right? So what I actually did was I grouped the first 2 and I grouped the last 2. So guess how this factoring is called? Guess what it's called? Factoring by grouping. Yeah. So I'm going to group the first 2 terms together, and I'm going to group the last 2 terms together. So look at just the first 2 terms. What do the first 2 terms have in common? What can I factor out of both first 2 terms? 2x squared. That's exactly right. They're both divisible by 2. 2 and 6 are both divisible by 2, right? And each of the exponents are both divisible by x squared. What's left if I divide the first term by 2x squared? Just x. What's left if I divide this term right here, the 6x squared, by 2x squared? Plus 3, right? Now, we ignore that and look at the last 2 terms. What do the last 2 terms have in common? And is that a trick question? Kinda is, right? Are they both divisible by the same thing? No. So what is the only thing they're both divisible by? 1. And here's the deal about factoring by grouping. I have to factor something out. So if I factor out a 1, what's left? Just x plus 3, right? Now, when I showed you this first example up here, I just did it for you. I didn't talk about any of our goals or anything, right? Do you notice that in this step right here, that I have a goal of getting the same parentheses? Didn't I do that right here? You might have thought it was just like a fluke. It was just lucky, right? Guys, if we're factoring by grouping, that's our goal. Our goal is that that parentheses that we have left over is the same. Because if it's the same, what can I do with it now? Factor it out, right? If I factor out an x plus 3 from each term, what's left? 2x squared plus 1. And that is the answer. I need to do one more for you. Okay? X cubed plus x squared minus x minus 1. How am I going to factor this? By grouping, right? How do I know I'm factoring by grouping? When there's 4 terms. Okay? So just look at the first 2 terms. What's common in these first 2 terms? X squared. That's exactly right. If I factor out an x squared, what's left? X plus what? 1. Wait, what's my goal again? The same parentheses, right? What's common in these 2 that I need to take out so that I get a parentheses that reads x plus 1? A negative 1. That's exactly right. Okay? If I factor out a negative 1, what's left? X plus 1. I've met my goal, right? I have 2 parentheses that are exactly the same, so I can factor those out. So if I factor out an x plus 1, what's left? X squared minus 1, right? Now this time, we are not finished. Why are we not finished this time? This binomial is the difference of squares. And we know how to factor the difference of squares, don't we? So I can't stop right here. I have the x plus 1 that I already had. How do I factor the difference of squares? 2 binomials. What goes at the front of each binomial? An x. What goes at the back of each binomial? The square root of 1, which is what? 1. And what can you tell me about the signs? They are opposite. That is now completely factored. If it just said factor, I mean, that's factored. But most of the time, the instructions will actually say factor completely. And if it says factor completely, this line right here is not factor completely because that's still the difference of squares. Does that make sense? Are there any questions? So do you feel comfortable factoring binomials? You got to look at them, right? What are you looking for? Is it the difference or the sum? And if once you decide if it's the difference of sum, you're deciding is it squares or is it cubes, right? You know the patterns for each one of those now. Do you feel comfortable factoring things with 4 terms? Factoring by grouping, right? What we just did. Why didn't we do 3 terms today? Oh, we have enough time for that tomorrow and the next day. We got time for that. Okay? Are there any questions?